Hello and welcome for capital markets in the security analysis for Ethiopia. In the previous, we have discussed different issues, and this is the continuation of the previous time. Mathematics for capital markets. We will see it today. Basic time value concepts we have said in the previous different issues about time value of monies or time value concepts. The money of today, small money of today is greater than big money in the future. This is what is time value of money stated about. Now let us discuss the illustration. Owner deposits 10,000 in the public bank, and where it will earn a simple interest of 9% per year. It deposits another 10,000 in the private bank, where it will earn compounded interest of 9% per year compounded annually. Where is annual or in annual one payments, or it is called as N. In both cases, Bona will not withdraw any interest until 3 years for the date of the deposits. Now our objective is to see the difference between simple interest and the compound interest by using the quantities or in numbers. We will see the difference in numbers. Then you can calculate simple interest by simple interest is equal to principal times interest rate times T. That is simply you can calculate principal is 10,000 times rate is 9% times 1 year is 1, and then it gives us 900 simple interest. This is how simple interest is calculated. Then since it is a simple interest, we can add 900 on our principal. We will accumulate our principals and the interest together. That is 10,000 and 900. This is accumulated year-end balance. This is the first year end balance is 10,000 and 900. This is principal plus our interests. The second year, or on the second year, the end of the second year, again we can calculate 10,000 times 900. That is also the other second year's interest. It is also the same, that is 900, because we can calculate the end of 1 year by using of 1 years. You can calculate 3 times. That is 900 again. The simple interest is constant over the 3 years. And also at the end of 30 years also we can calculate 10 times or principal times interest times 1. That is 9,000 or 900. Then we can plus on the accumulated year-end balance. Now the total interest is 900 times 3, that is 2,700, with that of the principal 10,000 plus 2,700, it becomes $12,700 or euro or birr. Now let us come to the other first state banks or compound interest calculation, we can calculate compound interest is equal to P in the brackets 1 plus R to the power of N. P is 10,000, 10,000 in the bracket 1 plus, the rate is 9, 0.9, the power of 1 years, or you can calculate total amount by making the power of 3, that become principal and interest become 12,950.29. This is when we calculate as the end of 3 years. But individually also we can calculate year by year. That is compound interest calculation of the first year is principal times interest times year. That is 10,000 times 9%. That become 900 for the first time. The simple interest and the compound interest, it is the same. But the difference will be occurred in the second because we can add on 10,000. The year-end balance is 10,900. This is for the next year. It become principal. It is become the principal. It is not like that of simple interest, which all the time 10,000 is the principal that is constant. The simple interest is also constant. But under the compound interest, we can add at the end of the years, we can take it to the second year as the beginning. We can add over the principal, and the interest also has another interest together. That is why 10,900 becomes the second year's beginning principal, not 10,000, rather it is 10,900 times 9%. The interest become 981, and then when we add 981 over 10,900, it become 11,881. Then 11,881 we can take to the third years as principal. It become 11,881 times 9% times 1 years, that is years. The interest become 1,069.29. Then we can add over our previous principal, that is 11,881, become 12,950.929. Then now let us see the difference between compound interests and the simple interests. We can get compound interest is 2,950.2.9 when we sum up total compound interest, and simple interest become 2,700. The difference between two is 250.29. This is overstated by compound interest calculations. This is the interest of interests. The interest of interest. This is how compound interest and the simple interest is different. On simple interest, only principal has interest. On compound interest, we can calculate the interest of interests. The interest of interest. That is why it becomes compound. Let us go to the next. The next, what is the number of periods? Or number of periods equal to number of years times number of compounding period per years. That is years minus number of compounding period or frequency of payments. How many times we can pay in the year for our interest. For example, if that is annually, M is 1. If that is semi-annually, the M is 2. If the if that is quarterly, M is 4, and the like. Then compound paid interest rate is equal to annual rate or rate divided by that of number of compounding period per years. That is I is equal to R over M. I is equal to R over M. N is equal to year times frequency of payments, annually or monthly or daily in the like frequency that you pay for the interest. Now let's go to calculate the future value of 1 at compound interest. That is the 1. For 1, let us calculate a future value. Future value equal to present value in the brackets 1 plus r the power of n or the power of t. So let us take p is principal, or p is the present value, that is 1 in the bracket 1 plus rate is 0.09. The year is on the period 1, that is 1. It become 1.0900. On the 9% we can calculate by using the 9%, we get the future value of 1.0900. For 10 also it is the same. For 11 also it is the same. Let us calculate on number 4. Number 4, the future value of 1 at compound interest is equal to present value is 1 in the bracket 1.09, that is rate. The power of period 4 is the power of 4. This become 1.41158. When you calculate by using the formula, you can get all of this one. So this is how can we calculate the future value. Future value is equal to present value in the bracket 1 plus rate the power of n or the power of year or the power of periods. The power of periods. That is how we can calculate the future value of 1 present value or $1 present value. Let us go again for the next. Compounding interest. How much principal plus interest dollar accumulates to at the end of each of 5 periods at 3 different rates of compound interest. Formula to determine the future value factors. Future value factor is equal to 1 plus I the power of n. What is I? I is equal to R over M, as we said before. That is rate divided by number of periods. Number of periods, or this is known as the frequency of payment. That frequency of payment. It is not number of periods, that is frequency of payment. Number of periods, or n, is equal to year times, as we said, year times the m, year times m. Then we can calculate factor of future values or future value factor for any period as I interest is equal to r over m. Now let us go again. Determine the number of the period n by multiplying the number of years. N equal to, as we said, year times m. Year times m, or number of compounding period, or that is frequency. It is frequency. We can say that frequency of payments. Number of periods equal to year times m. Now calculate number of periods. For the first time, 12% annual interest rates over 5 years compounded. This is 12%. R time is 5 years, or year is 5 years. Now let us calculate for annual 1 interest rate per compounding periods. I is equal to, as we said, I is equal to r over m. Look the formula above, r over m, that is interest rate per compounding period. So our interest rate is 12 divided by our year is annually, our period is annually, that is m, or annual it is 1. So 0.12 divided by 1 is equal to 0.12. This is interest rate per compounding period. What about number of compounding periods? That is number of compounding period is equal to, that is n is equal to time or year times m. So for the first one, m is 1, that is annually, it is 1 time payment. The time is 5, the year is 5, 5 times 1 compounding per year is equal to 5 periods. For the second semi-annually, m is 2, r is 12, then 0.12 divided by 2, that is m, r over m is equal to 0.06. Then now m is 2 on semi-annually and t is 5. Now we can calculate number of compound period 5 times 2, which is 10 periods. And like for monthly, for example, monthly, our m is 12 and our interest rates, the annual interest rates, or r is 12%, then 0.12 divided by 12 is 0.01%, or then number of the period 5 years times our m is 12 when we calculate with 12 we can get 60 periods, that is n is equal to 60 periods. Then let us go again. Now let us see our compounded interest, that is 9% annual interest compounded daily, provides 9.42 yields, effective yields for 10,000 investment. This is effective yields. How we can calculate effective yields, or our effective yield can be calculated and we can get around 9.42, the place when it is circled. You can get by using the formula. This is effective yields. Then the next, fundamental variable to compound interest. To calculate the compound interest, we have to know in rate of interest, number of time periods, present value, future value. the present value that you see at 0 points. Interest rates, those numbers are numbers of period, and the future value are the in 5 years. Let us go again. Single sum problem. Two categories. Unknown present value. There is present value unknown. Unknown future value. That future value unknowns. How can we get? Let us go again. Future value of single sum. The value at future date of the given amount invested assuming compound interest is future value is equal to present value times future value factor. That is future value factor we said is 1 plus r to the power of n. This is future value factor. Or we can calculate by using future value is equal to present value in the bracket 1 plus r to the power of n. We can calculate by using this, or we can calculate by using future value factor for n period at I interests. First of all, we have to calculate future value factor, that is 1 plus r to the power of n, or I to the power of n, we can say. This is future value. Then we can multiply by that our present value, and then we can get future value. Or future value is equal to present value in the bracket 1 plus r to the power of n. We can get in both cases. Let us see again. Future value of single sum. Illustration. Ali wants to determine the future value of 50,000 invested for 5 years compounded annually at interest rate of 11%. Now let us identify the component. First of all, present value is what is invested is $50,000 time, that is 55 years compounded annually. Our M is 1, that is annually, and the interest rate or R is that 11. Then let us calculate our future value. Future value equal to present value in the bracket 1 plus r to the power of n, or present value in the bracket future value factor times present values. This is how can we get in both cases we can get it. First of all, you have to calculate factor value, that is 1 plus r to the power of n. And then when we calculate factor value, we get 1.68506. This is a factor value. How can I calculate factor value? Factor value equal to 1 plus r to the power of n. R to the power of n, or r to the power of t. Since m is 1, m times t is equal to n, so that is 5. When we calculate 1.11 the power of 5, we get 1.68506. Then multiply it by present value, we can get around 84,000. The sum, when we calculate, we will see the features, but around 84 or something. Illustration. I want to determine the future value of this invested for 5 compound annually at interest rate of 11. Alternative calculation. We can calculate by using different other alternative method. That alternative method is this way. We can calculate individually by having of period 1, period 2, period 3, period 4, period 5. At 5, we can get factors. That's 1.68506. This is how can we calculate? Then present value 50,000 times factor we get individually, period by period. Period 1. On period 1 we get this, on period 2, on period 3, on period 4, on period 5. Then our aim is on period 5. Then we can get 1.68508 we get. Then when we multiply that is 84,253 something. This is how can the above also the previous slide value also $84,253 is future value. Today you invest $50,000, then in the future you get 84,253, or your interest, total interest is 34,253. The principal is 15. Again, the future value again, Caleb invests 15,000 today in the funds, that is present value, that earns 8% compounded annually. It is compounded but annually. The M is 1, then R is 8. To what amount will the investment grow in 3 years? That is future value. To what amount this 15,000 is growing in the 3 years, at the end of 3 years. Let's go, this is future value. How can we get future value? In single ways, we can get by such methods, but we can directly get by using future value formula. Future value equal to present value in the bracket, future value factor, or 1 plus r to the power of n. Our r is 8, so 1.08 the power of that is 3. The power of 3, which we can get 1.25971 times 15, that is $18,896. This is our future value. The next Caleb invests 15,000 again today in the funds that earn 8 compounded annually. To what amount will the investment grow in 3 years? That is also how we can prove. We can prove in simple ways. Period by period. On period 1, we can get interest of 1,200. When we add on to the balance, so on to the principal, it becomes 16,200. Then in that way, we can add all of the interest down, and we can add this on our principal, and we can get 80,896 as before. Then there is also another, the future value can invest is semi-annually. If that is semi-annually, our M is, or frequency of period is two times in the years. So M is 2. M is 2. Now we can calculate by using the following ways. Our factor is 1.2653, or you can get the future value equal to present value in the bracket 1 plus r over m the power of n times t times m. Now it is changed because that is semi-annually. It is semi-annually. Then if that is semi-annual, our future value is equal to present value is 15,000 in the bracket 1 plus r. Our r is, as we said, our r is 0.08 divided by 2, that is 1.04. The power of our period is, or our n is m times t. Our m is 2 times t is 3, that is 1.04. The power of 6 is 6 times 15,000. It becomes 18,980. We can calculate by using this also. Have you seen how we can use, or how can we calculate if our M is changed? If our M is changed, we can calculate by using different components. For now, for example, our M is 2, then our calculation is future value is equal to present value in the bracket 1 plus R over M. This is our I, small I, our interest. Our interest is R over M. The power of, it is not the power of T, rather it is the power of N. What is N? N is equal to T times, or year times M. M is 2, our year is 3, that is N is equal to 6, that is 6 times in these 3 years that the payment is undertaken. So we get a future value of 18,980. The second, present value of single sum. Now, how can we calculate? We can calculate the present value. The value now of a given amount to be paid or received in the future, assuming compounded interest. Present value means what amount of money we have to invest today to get something in the future. Present value equal to future value times present value factors, present value factor for n pairs, or present value equal to future value over 1 plus r to the power of n. You can get in 2 ways. Look, illustration. What is the present value of 84,250 to be received or paid in 5 years, discounted at 11% compounded annually? Then present value equal to present value factors, that is present value factors equal to 1 over 1 plus r to the power of n. This is present value factor. Future value factor, we have said 1 plus r to the power of n. We have said. Now our present value factor is 1 over 1 plus r to the power of n. So it is the same, only what I have to reciprocal is the difference. Or we can get present value equal to future value over 1 plus r to the power of n. We can get in 2 ways. Now let us calculate by using the first ways. 84,253, that is present value, in the brackets present value factors, that is 1 over 1 plus 0.11 the power of 5, which become 0.55934.5, that is 50 point something like that. The next we can get by using, look how we can get, we can calculate the factors. Our factor is also individually, we can get on the period 1, on the period 2, on the period 3, period 4, on period 4, and on period 5 we get the present value factor, that is 0.55934.5. Then we have our present value, that is $84,253 times 0.59345, that is present value factor, that become 50. So it is the same. Also you can get by using future values. Present value is equal to future value, that is $84,253 over 1 plus or 1.11 the power of 5. If you divide this one, you get 50,000 points, something like that, present values. That is the same. So you can get in 3 ways. This is easily you can get by using simple formula, but there is a different formula. Tom needs 25,000 in 4 years. What amount must he invest today if his investment earns 12% compounded annually? This is compounded, but it is annually. M is 1. So what is asked? That's present value. Tom needs 25,000 in 4 years. At the end of 4 years, its future value is 25,000. This 25,000 is will be earned as at the end of 4 years. But today, what amount of the money or the dollar or the euro or other currency or birr should Tom invest? This is present values. This is future values. This is present value. With the same style, we can calculate this individually. Our factor is 0.6355 because our n is at 4 or our time is 4. Then by multiplying with future values, present value factors with future value, we can get 15,880. Also, you can get B. This is the end of today's program. I thank you for your views. Please, if you like, subscribe, like, and share to my YouTube. Next time we'll learn calculations of EATs, that is time value. The others also there is another calculation on time value of monies or time values. My YouTube, as you can see, is this one. I thank you very much.